Quadratic functions. We've done a little bit of that already. Last week we did linear functions where we graphed lines, we found slope of lines, wrote equations of lines, did some domain and range, stuff like that. Okay, so for quadratic functions, they look like this. Now, this is what we call standard form. Last year and any other book that I've seen, but the book you have, they don't call this standard form. They call it something different. I'll show you in a few minutes here what they call standard form. But this is what we were taught last year, what you were taught about standard form for a quadratic equation. Ax squared plus bx plus c. A, b, and c are numbers. We've talked about that when we've done factoring and stuff like that, these quadratics. Okay, so the graph of a quadratic function is a parabola. Okay, if the a value is greater than 0, meaning positive, that number right there, it has a positive attitude, has a smile on its face, right? If the a value is less than 0, meaning negative, it's got a bad attitude, so it's got a frown on its face, all right? So think of positive attitude, negative attitude, okay? So when it's in standard form, when it's in this form, you look at this number in front of the x squared, you can tell if your graph will open up or down. That dashed line that's down the middle of those parabolas is called the axis of symmetry. Okay, the parabolas are symmetrical. That axis of symmetry, the way we figure it out, if it's in standard form, is this little formula here on the right. X equals negative b over 2 times a. And again, the b and the a are from the b and the a in this function. The a spot number and the b spot number. All right, so that's how you find it's x equals that. Remember, when you have an equation of a line that's x equals, no y in it, we talked about this last week, the week before a little bit, it's a vertical line, okay? So we're just looking at parabolas that are open up and down right now, when the x is squared. We've talked about when the y was squared, they open sideways, okay? But this axis of symmetry is that vertical line right down the middle. And the way you find it out is substitute the b value here at the top and go 2 times the a value. Whenever that comes out to be, sometimes it's a fraction, sometimes it's a whole number. That's what we use for the axis of symmetry. Okay? Once we know the axis of symmetry, we can figure out the vertex. Okay? The vertex is right at the very bottom if it opens up, or at the very top if it opens down, and it's a point that's on that axis of symmetry. Okay? So there's a little formula also for that. Okay? The x value of the vertex is whatever you got for the axis of symmetry. So let's say it was x equals 3 when you were done using that little formula. The vertex would be 3 in that spot, and then f of 3, meaning you put 3 up in for x up here and figure out what f of x is. That's the y value of the vertex. Okay, so what we're going to do to find the vertex is whatever we got for x equals for our axis of symmetry, we're going to substitute that number into the original function and figure out the answer, and that answer is the y value of the vertex. Okay? And then there's usually a y-intercept somewhere on these, and that's always x value 0, and then it's the c value of the original problem. it's always this value up here. That's always the y-intercept. Okay? But remember, all y-intercepts, the x value is 0. So if I were to substitute 0 in for x, you'll get whatever the c value is. Okay? Right, Eaton? Right, Wagner? You guys are paying attention, not doing something else? Showing me a little respect? Okay? Any questions so far? Now, your book calls this standard form. We've always called it, that's what you were taught last year, that's called vertex form. And I'm still going to call it vertex form. Okay? This A value here is the same A value up in standard form. Okay? But what we have to do is we factor the function so that it will be written as a binomial squared. So we're going to do what we call complete the square, which we've done this year. Okay? And plus k. This hk, if it's in this form, these two numbers tell you the vertex. That's why we call it the vertex form. Okay? And then your axis of symmetry will be x equals whatever this number is. Okay? So if it's already in this form, okay, which again your book calls standard form, but I'm still going to call it vertex form. Some of the problems you have to do is, sorry about that, it'll give it to you in this form, which we call standard, and it'll say put it in standard form. Okay? What they're meaning is to put it in this form. Okay? And then, now there's a couple ways we can do that, and I'll show you. If you want to figure this part out first and then just substitute to make it look like that, you can. Or I'll show you the other way, using completing the square. Okay, so this one, the A value is 3. The vertex is going to be 2, 4. Okay? So when this vertex form is always x minus h. So whatever makes this 0, if I plug a 2 in for x, 2 minus 2 is 0. That's the x value of the vertex. And then whatever this is the y value of the vertex. Okay? So that means my axis of symmetry would be x equals 2. When it's in this form, I can write those two things right away. Okay, then if I had to find the y-intercept, so I could graph it, I would substitute 0 right there and figure out the answer, and that would give me the y-intercept then. And then I could graph it because I know it's symmetrical. Okay, again, I'll show you that here in a few minutes. And again, we did all this last year. We've done a little bit of this already. Okay, so this is the type of problem you're going to have. You're going to say, put that in your book's going to say, put that in standard form, which really means put it in what you're used to calling vertex form. Okay, so it says, here's what the directions say. Use the method of completing the square to find the standard form, which really is what we say vertex form of the quadratic function. State the vertex and axis of symmetry of the graph of the function, and then sketch the graph. All right, so that's part of what you're doing, and that's part of what you'll do for your quiz. And your quiz will say, put it in vertex form, and, find the vertex, the axis of symmetry, and sketch the graph. I think I even tell you to remember to do the y-intercept on the quiz directions. Okay, so the method of completing the square. A has to be 1. What's A right now? It's 2, thank you, man. So in order to change the 2 to a 1, I got to divide everything by 2. Okay? Or I can factor out the 2. All right? So when we complete the square, we keep the A part and the B part on the left, and we take this C part and move it over to the other side or the right side. Okay? So we're going to factor out the 2. That's my A value. So that gives me a 1 now in front of the x squared. That's how. Then I can complete the square. And then factoring out the 2 makes a 12 a 6, just dividing the 12 by 2. All right? And then I add this blank. All right? Now, the tricky part, or the part you have to remember, since you factored this 2 out, you got to remember to multiply your blank by 2. Because if I go back and try to get to the original problem, I would distribute the 2. I'd be multiplying my blank by 2, which would be 18. So I got to make sure over here I'm adding an 18. So I remember to multiply my blank by 2. The way you get the blank, you take B, the B value divided by 2. So 6 divided by 2 is 3, and then you square it. Okay? So 3 squared is 9. That's where the 9 came from. All right, so what we did is we made this, by completing the square, we made that one of those special trinomials that you can factor by taking the square root of the x squared, whatever's in front of the b is a negative this time, minus, and then the square root of the blank. So that's how we get to this part here. So the square root of x squared gave me the x. The square root of 9 gave me the 3, and whatever was in front of my b goes in between. The 2 still drops down. And then I just did negative 19, and 9 times 2 is 18. So negative 9 plus 18 is how the negative 1 got over there. Okay? So what I was doing over here on the left was trying to find the axis of symmetry using this little formula. Okay? So if you wanted to, you could do negative b over 2a. Negative b would make it positive 12 over 2 times a, which was 2. 12 divided by 4 is 3. Okay? Whatever that is your axis of symmetry. Okay? And then if I add the 1 back over here, I have it in that vertex form, which again makes my vertex 3, 1. If we were to substitute 3 all the way back here, 3 squared is 9 times 2 is 18. Negative 12 times 3 is negative 36. So I've got 18 minus 36, which is negative 18, plus 19 would give me a 1, which would give me the y value. The y value of the vertex. So we would get 3, 1 here. Okay? And if we look, HK 3, 1 is our vertex. Axis of symmetry is x equals whatever you got for the, x equals h. It keeps jumping on me, sorry. Let's get rid of it. So that makes my axis of symmetry 3 there. Now, how do you graph it? Okay. We know that the vertex is 3, 1, so I find that on my graph. I know my axis of symmetry is x equals 3, so it's that vertical line goes right through the middle of it. All right. In order to figure out the y-intercept, okay, you can look at the c value, or you can remember if you wait till you get to here, you can substitute a 0 in there. 0 minus 3 is negative 3. Negative 3 squared is positive 9. Times 2 is 18, plus 1 is 19. So either way, you can get 0, 19. The way I get this 6, 19, all right, is look at this axis of symmetry. How far is the y-intercept from my axis of symmetry? How many spots? You see 3 spots there, don't you? I'm 3 spots away from the y-axis, right? To the left. So since I know it's symmetrical, I go 3 spots to the right. All right? So this is 0, 19. Right there in the middle would be 3, 19. If I go 3 more, that's 6, 19. So there's my 3 dots that I can draw my parabola, my curve, to graph that. Okay. So again, I went pretty slow there. But that's the type of problem you have. You have, let's see here, 1, 2, 3, 4 of those for part of your homework. Okay, where they start out looking like this, which we call, again, standard form, and they want us to turn it into this form, which the book calls standard form. Okay? So, that's completing the square. Factor the 2 out. If that's a 1, I don't have to do that step. Okay, if that's already a 1, I just go from here, plus blank, take the C part to the other side, plus blank, and I don't have to worry about this 2. Since that 2 was there, or if it's a 3 or a 4 or 5, whatever it is, factor it out. Divide that number by whatever you factored out, and then take half of B, so half of 6 was 3, square it. That's how I got the 9. Okay, B over 2 squared fills in the blank. It's always plus blank. It's always the B value divided by 2 squared. Okay, we've done that already this year. You should already know that, but just a review. Okay? Whatever you get over here after you do your math, remember, since I factored a 2 out, the blank is times 2. If I would have factored a 4 out, it's the blank times 4. Whatever you get, you bring it back over, so it looks like this. What we call vertex form, which your book calls standard form. Okay, figure out the vertex. Your axis of symmetry goes right through the middle of the vertex. Find your y-intercept, and then go straight across. Remember, it opens up when A is positive. This was a positive 2. That's why it opened up. If A is negative, it opened down. Okay? Questions? Now you guys are still kind of in lounging Thanksgiving mode. Sign, you keeping up? Yeah. Are you playing games on your phone? Good. No questions? All right. Min or maximum value. You have 3 problems. You have 3 problems like that, like this. Okay. And the minimum or maximum value is the y value of the vertex. What you got to do is figure out the vertex. Whatever the y value is the min or max value. Okay? Again, if A is positive, it opens up. You got this vertex at the very bottom. That's a minimum. If your A value is negative, then your parabola opens down and your vertex is at the very top, so that's a maximum. So if it opens up, you're looking for a minimum. If it opens down, you're looking for a maximum. Okay? So, in this problem, this example, what's my A value? Positive 1. So does it open up or down? Up. So am I looking for a min or a max? A min. Right? When it opens up, we got the very bottom is where the vertex is. We're looking for a min. So in this problem, we're looking for a min. All right? The quickest way to do it is to figure out your axis of symmetry. So what's negative b? Negative 6 over 2 times 1. What's negative 6 divided by 2? Negative 3. Okay? All right, this is going to be a min because it opens up. All right? So all we do is we put whatever we get here in for x. That's all we got to do to find our min value then. Negative 3 squared is positive 9. 6 times negative 3 is negative 18. So 9 plus a negative 18 is like 9 minus 18, which is negative 9 minus 1 would be negative 10. So our minimum value would be negative 10. My vertex, if we had to figure it out, would be negative 3, negative 10. This number, remember, is the y value of the vertex. This number, whatever you get for the axis of symmetry, is the x value of the vertex. Okay? If we had to put this, I'm just going, you don't have to do any more than that. But just going back to the first problem. If I had to put that in vertex form, right, we have f of x equals a, which is a 1. You don't have to put the 1, but I will. X minus h, what's minus a negative 3? Squared plus k. K is your y value vertex, thanks, which would be minus 10. Okay? So, it says to use the method of completing the square, but you could do this method too. I just showed you a different method. You could find the axis of symmetry first. Then substitute that number into the function to find this value, which is the y value of the vertex. Then you could just substitute this for h and k, and then whatever your a value is goes in front there. And then you'll have it in what we call vertex form, what your book calls standard form. Okay, so if you don't like that complete the square method, you could do it this method. Right, Austin? So that's the 2 types of problems. Min or max, you got 3 of those. Okay? Changing it from standard form to vertex form is the other type. You got 4 of those. And then they have you look at a couple graphs to figure out what equation goes with what. All right? So it's not that much homework. And that's what's going to be on your quiz, those 2 types of problems. Quiz will be Friday. The 36, 39, and 42 are the min-max problems. Numbers 9 to 18 are the first type. And 3 and 6 was just matching a parabola to an equation. So again, Brandon and Zach Ivan, Austin and Andrea, you have the quiz to make up that we took last Tuesday. So let's get that done by Thursday this week. I'll give you 2 days to take care of it.